YouTube, Electric Adventures here with the next episode of Electric Adventures the Games. Last time we looked at tennis of program pack 9, and this time we move on to number puzzle. Also not a really big program, but it demonstrates what you can, clever things you can do with sprites, and how you can get things to look. So let's run it and have a look. So we have our usual title screen. A little bit of a pause here because, as I mentioned, this has quite a lot of sprite shapes, so it took a little bit to load. Press any key to start. So blanked out our screen. It's having a bit of a think, and we have a sliding number puzzle. So what the whole idea is, you've got to try and get the numbers in order. Oh, and we have sound this time. Yes, it's always nice to get some sound. I haven't actually played one of these for a while, so I'm probably going to be fairly rubbish. What do we do here? Need to get these all the way up the top, don't we? I suppose I should have a semblance of a go at trying to done number puzzle for ages. So I've left my number 3 down the bottom there. So it's a great little slide puzzle which can keep you going for ages. We probably need to. Actually, that's the wrong one. We need that. Except, stupid me, I've put them in the wrong spot. Which means you need to shuffle these around a little bit. I need to have a practice doing slide puzzles, aren't I? I'm not going to get a very good score on my own slide puzzle, so don't expect me to solve this now, or we could be waiting quite a while. Okay, got ourselves a bit of room now. And finally reverse those. I probably could have done that a much easier way. So potentially we can at least get our first row. The people out there are probably screaming at me. You're doing it all wrong. So there we go. I've done the first row. A bit of mucking around, I could probably get a bit more done. See, I've left the 7 down the bottom. So you've got to allow yourself enough room to actually move the pieces around and get them in the right spot. Now we need to. That's better. And I should be planning for the next row. Whoops, I didn't do that. So there we go, I've got 2 rows. That's probably a good enough demonstration. I'll probably embarrass myself if I try and finish it, but as you can see, it's actually quite a nice little playable game. We even have a tiny sound effect, but at least we've got a sound effect, and it looks pretty cool. And has a reasonable harness and randoms things up a little bit. So, alright, I'll get the source code out so we can have a look. Alright, back. So, got it set up, loaded our source code. Let's see how long it is. So there's not actually a lot of logic there, and there's a lot of data, and there's a lot of data because there are obviously 10 16 by 16 sprite shapes used for the tiles, for the different number tiles. So, oops, if I can type, let's have a look at our code. Not too much. Okay, so line 10, this is a very common thing. It's pretty much the same as everyone on this pack so far. So clear a bit of room, set our default colours, set up our screen mode, make all our variables integers, which makes things run faster, and define our random function and open our handle to the graphics screen. Line 20, restore. That restores the data commands back to the start. Those are pointer that basic keeps. Sets our colour we want to use and a slightly different screen mode. I just don't know why I changed the screen mode twice. And the screen mode 2.3 makes the sprites large. So we're making 16 by 16 sprites 32 by 32 by magnifying them. So it sets them in magnify mode. We dim an array 4 by 4, which is our grid. Line 30, we change the colours again, even though we haven't actually used the colours very much, and it's the same background colour. Clear the screen. Preset it a bit, that's how we set our pointer to a particular spot. Oh, hello Tabby in the background there, that's our other cat that you don't see very often. Just said hello to everybody. We print the word number puzzle, no overprinting to make the thing thick, and then we read in 16 sprite shapes, which obviously is the thing that takes a bit of time. So read in all those. Line 40, we set the pointer a little bit lower down, different colour, and we put press any key to start. And we wait for any key to be pressed. So it's not controlled by the joystick, this particular one. We're waiting for any key on the keyboard to be pressed. After that, set a slightly different colour combination, clear the screen, and we clear out that 4 by 4 array. And then we calculate our number puzzle. So doing 15 values, doing a random XY, and each time we place one of those we make sure that the position is clear. So at the start, when we go to place our first number, it's not going to have any trouble finding a position because they're all blank. The second one is going to have a small chance of being in the same place as the other one. So that's why it can take a certain amount of time before it hits and gets a free square near the end, and why it takes a little while to generate the random grid. Now, the good thing about slide puzzles, these slide puzzles, they are always solvable. Just depends on the number of moves, can just depend on how randomized it is. So basically that one line randomizes the puzzle for us. Oops, we've gone over a little bit there. I'll clear the screen again. I'm having typing problems today. Okay, line 60. Right, so line 60 puts number puzzle in a string and puts that up the top of the screen, 1 pixel apart, so we do use our bold text there. And then we draw our outer box, and then we draw an inner box inside that, so that it gets us a hollowed out box. And then we put our sprite shapes based on our random positions. So it uses, and this is really cleverly working into, you can only have 4 sprites per line, so we don't have that problem with this one because the maximum number of pieces across is 4. It goes through our array and puts the appropriate tile in each spot. And I obviously have a blank one as well to handle the 0 position. And after that, I go to 80, so line 70 must be a subroutine or something. So line 80, we'll skip 70. On 70, we play a sound. And we go sub and we go to the next line anyway. We'll work out line 70 later. So it's probably our move tile, sound and moving the particular tile from one spot to another, depending on the direction of the joystick we did. At line 80, we look at the direction of either the keyboard or the joystick plugged into port 1, and we use that wonderful on value go to statement to go to a different line depending on the direction we're going to. So for each one of those, I need to see whether the square directly above well, first we need to find the actual square. Yeah, we find the empty square, and so if we're going up, the piece we're going to move is the one below that one. And the only time you wouldn't do that and abort is if the empty square is at the bottom. So if you're at the bottom, there's no piece to move up, so we abort. And that's what the first section of, so if b equals 4, go back to 80 does. Yeah, and you notice the on go to statement ignores the directions that don't do anything, so it ignores all of our diagonals. And we're ignoring direction value 0 as well. So line 100 specifically moves one of our sprites for one spot to the other and empties out the current sprite. So we're using the values A and B passed to that little subroutine. This code's a little bit more meshed together rather than being in order, isn't it? Goes to something, then we go back around 80. So this 80-90 section is our main loop, and whenever we actually do move this place, we go back to 70 to play the sound and move the sprite. So it's very, very constrained code. It's interesting what my brain was going through at the time. I'm interested to know what I'm pressing on the keyboard to make it jump up like that sometimes. But anyway, let's have a look at other things. I think we're into subroutines now. Oh, these are more of the directions. So these cover off moving to the moving up, down, left and right between all 4 of those. They do exactly the same thing, just dealing with different directions. 200. There's the last of the ones there. Okay, so line 170 was a subroutine. This increases our moves by 1. And what it's doing is checking to see whether we've completed the puzzle. And if we have, we go to the next line. Otherwise, we go back from the subroutine. If we've completed the puzzle, line 180 puts up solved in M moves, which is our number of moves we've made, plays a little sound. It actually looks like we use some randomness to maybe play a bit of a random sound. It'd be interesting to know what that sound is. It restores our data back to normal and clears off all our sprites and jumps back to the title screen. And there's a delay in there, so you can actually hear the sound playing and things. So very simple, and the rest of the program, so 200 onwards, are all of our sprite shapes. So each one of those define one of the numbers in the puzzle. So yeah, it's actually quite a nice little puzzle game and shows once again what you can achieve with very little effort on the MSX and Spectravideo machines. So I hope you're enjoying this series, looking at my older games that I wrote in the mid-80s. I'm Electric Adventures. Thanks to all my subscribers. Thanks for watching, and I'll catch you next time.